Let's take a look at these two examples. So the limit is x goes to infinity of 1 plus 1 over x raised to the x. Now this one I already talked about in a previous video. I gave you a fact, but we'd like to figure out how do we know that that fact is true. So I'm not going to remind you of the limit. We're going to calculate the limit now by hand. So when we look at the base, remember 1 over x, when x goes to infinity, that's going to 0. So this whole thing is going to be going to 1, and the exponent here is going to infinity. So 1 raised to the infinity is one of our indeterminate forms. We don't know if it's going off to infinity, going to 0, staying at 1, where is it going? So we now need to figure out how do I deal with this. So this is where we use our exponential form, trying to figure out exponential form with indeterminate forms. So remember, I mentioned this in a previous video talking about how maybe using logarithmic differentiation ideas might be helpful, right? Because logarithms are really good for exponents. However, we do not have an equal. We don't have something equal to another that we can apply the log to both sides. So I need to figure out how do I use logarithms without changing this expression. So we're going to use a special property with e and natural log being inverses of one another. I'm going to rewrite this. Limit as x goes to infinity of e to the natural log. Remember, e to the natural log, because these are inverses, they basically cancel out, and all we're left with is what's here. So what's going to go here is exactly what's up there. So I have 1 plus 1 divided by x raised to the x. And this is on the inside of natural log. Now, when I'm taking the limit, the base is still going to stay e. I'm really just only taking the limit of the exponent. So I'm going to just stop, separate that out, and then return that to the exponent of e at the very end. So let's just look at the exponent. So considering the exponent, so I have the limit as x tends to infinity of natural log of 1 plus 1 over x raised to the x. Now we said natural log has the really nice property that you can move exponents down front, so we will do that. So this is the limit as x tends to infinity of x times natural log of 1 plus 1 divided by x. Now if you take a look at this again, taking the limit at this point, this is going to infinity, this is going towards 1, natural log of 1 is 0. 0 times infinity, indeterminate form. So we don't expect anything to be cleared at this point because we're just changing the style of indeterminate form that we have. So remember, the trick that we had is now when I have this multiplication, I'm going to leave the log on top, and I'm going to move this down to the bottom, still keeping the expression equal to x. So this is the limit as x tends to infinity of natural log of 1 plus 1 divided by x over 1 over x. Now we're at a point where we can use L'Hopital's rule because our indeterminate form is in fractional form. This will be 0 over 0. So now we use L'Hopital's rule. This has the limit as x tends to infinity. Actually, I'm going to use it right on the next line here. This is going to have L'Hopital's rule. Limit as x tends to infinity. The derivative of natural log of x. This is going to be 1 divided by this, 1 plus 1 divided by x. But then the chain rule says I multiply by the derivative of 1 over x. That's going to be negative 1 divided by x squared. And on the bottom, I'm now taking the derivative of 1 over x. So I get negative 1 divided by x squared. This is really quite nice because now I can just cancel these expressions. You can do that in limits. And then now I have 1 divided by 1 plus 1 over x. That's all I'm taking the limit of. Limit as x tends to infinity of 1 divided by 1 plus 1 divided by x. This guy is going to 0. So this just makes it 1 divided by 1, which equals 1. But that was just the exponent. That is not our limit. Limit is not 1. Remember, this is just the exponent. So this goes back on top of e. So what that tells us then is that the limit as x tends to infinity of 1 plus 1 divided by x raised to the x is equal to e to the first, or in other words, just simply e. So there we go. This is how we use this whole thing of e to the natural log trick with L'Hopital's rule to evaluate a limit that is an indeterminate form that is an exponential style. So here, let's take a look at one other example of this. So the same process is going to take place here. The base is going to infinity, the exponent is going to 0. Infinity to the 0 is an indeterminate form. So I'm going to do the e to the natural log trick. So this is the limit as x tends to infinity, e to the natural log of x to the 1 divided by x. Then what we have at this point is we just consider the exponent. So let's consider the exponent. So this is now the limit as x tends to infinity of natural log of x raised to the 1 divided by x. So I'm just looking at this exponent. Now at this point, what did we say we do? Well, we said that we want to bring down the exponent because we have natural logs. So this is equal to the limit as x tends to infinity, 1 over x, natural log of x. Now, as x goes to infinity, natural log of x goes to infinity, so we have natural log of basically infinity going to infinity, and 1 divided by x, that's also, well, this is going to 0, so I have 0 times infinity, that is an indeterminate form. But turn this into fractional form, super easy at this point, right? It's already basically in fractional form. So I take the limit as x goes to infinity of natural log of x divided by x. Infinity over infinity, L'Hopital's rule, take the derivative of both the top and the bottom. So the derivative of the top, this one's tricky, right? Remember, natural log is this outermost function, so we have to use chain rule, right? So when I'm taking a look at the derivative of this outer function, what is x tends to infinity? This is going to be 1 divided by natural log of x. So that's I rewrite the inside down here. Then I have to take the derivative of natural log of x, which is the inside. That's going to be 1 divided by x. And I take the derivative of x, and that is going to be 1. Now I have on the bottom here, this is going to infinity, this is going to infinity. Everything is going to 0 up here. That's going to 1. 0 divided by 1. This thing is going to 0. That is not our answer. Remember, that is only the exponent. So we now say that our final limit, as x tends to infinity of natural log of x to the 1 divided by x is equal to e to the 0, which is just simply 1. So there we go. So hopefully now you see a little bit more of L'Hopital's rule. Hopefully these things make sense. Just a few reminders. Notice again the equal signs where they appear. I'm not saying that this is equal to this. I separate this. There's no equality sign in front of this. Also, notice that I have not dropped my limit until I evaluated the limit. Once I've evaluated the limit goes away. So, just a few reminders to help you think back to the correct limit notation.